Hello ladies and gentlemen, so here's another question that's involving logarithmic differentiation. It's a different scenario than the last one. We don't have that special function that's variable to a variable in this case. In this case we have just an ugly looking function. We can use logarithmic differentiation to help us out here. What we can do is introduce a log of both sides. So it'll be the ln of f of x equals the ln of e to the x squared plus 1 to the 1/2 all over x squared plus 2 cubed. Now, since we've taken the log of both sides, log base e, I can do the derivative of this. This I could do the derivative of it. It would be 1 over, then times the derivative of the inside. But the derivative of the inside is a real mess, ladies and gentlemen. I don't even want to look at that. So I'm going to take advantage of some properties of logarithms that we have, and I want to start breaking this up. Subtract. Now that is a heck of a lot easier than trying to take the derivative of the inside. I'm going to simplify this up a little bit more. Well, this is ln e, log base e of e to the log base e of e to the x, which is simply x. This I'm going to bring the 1/2 down. This I'm going to take the 3 out front. And now I think I'm ready to take the derivative. So the derivative of this is going to be 1 over that. Derivative of x is going to be 1. The derivative of this, well, the 1/2 is outside the derivative. The derivative will be 1 over x squared plus 1 times the derivative of the inside, which is 2x. Subtract 3. The derivative of 1 over x squared plus 2 times 2x. Yeah, there you go. There's my derivative. Now simplifying it might take a little bit of work. Simplifying, let's make it look a little bit nicer. It's going to be 1 over f of x times f prime of x. Remember, this is what we want. We're going to isolate for this in just a moment. It's going to be 1 plus x over x squared plus 1. And it's going to be minus 6x over x squared plus 2. And let's see. Unless I'm really worried about it, since I'm just mainly teaching derivatives at this point, I'm thinking that we could leave it at because if I don't have to set it equal to 0 or anything, there's nothing wrong with me leaving like this. Now, if I needed to, I could get a common denominator and work this out. But again, I think in terms of teaching you how to do logarithmic differentiation, this is okay. So this was a different scenario. I didn't have a function that I couldn't take the derivative of without logarithms. I just had a function that I'd rather take the derivative of its separate logarithms, and that would be a lot easier. Again, I didn't have to go to ln e. I could have done log base 10, but do remember that when I take its derivative, I then would have had 1 over ln of whatever the base was, ln 10 or ln 3. So that would have made this a little bit more interesting as well. There you go, and we'll be back in a moment.